Dear students, Assalamu alaikum. This is lecture number 2 of chemistry. The topics that we are going to study today are atomic number and mass number, relative atomic mass and atomic mass unit, and chemical formulae. The topic of basic definitions has been covered in a separate video and that was uploaded last week. Now let's start these topics. First one is the atomic number. Now atomic number, as we already know that there are present electrons, protons and neutrons in an atom. Protons and neutrons are present inside the nucleus and electrons are present outside the nucleus. The number of protons for all the atoms of a specific element is always same. So that number of protons is equal to the atomic number. The atomic number of an atom is equal to the number of protons present in the nucleus of its atom. It is represented by symbol Z. Now each atom has its own atomic number. It means that we can identify an atom through its atomic number. If you look at the periodic table, there are given the elements are arranged number wise. Now that number through which these elements are arranged is the atomic number of these elements. Like if at number 1 there is present hydrogen. If you look at the periodic table, there is a separate chapter of periodic table and we will study that too, but for now you can check that at number 1 there is present hydrogen. So this number 1 is actually the atomic number of hydrogen. All the atoms which have one proton in the nucleus will always be the hydrogen atom. Atomic number of an atom cannot be changed, means atomic number of protons of an atom cannot be changed. Okay, so atomic number is used to identify an atom. Like if we discuss the example of carbon, there are 6 protons in the nucleus of a carbon atom, so the atomic number of carbon is 6. Next is the mass number. Now mass number, it is the sum of the protons and neutrons in the nucleus of an atom. Protons and neutrons are present inside the nucleus, so by adding their number we can get the mass number of that atom. The symbol that with which the mass number is represented is A. Now look at this equation, that is mass number is calculated as A is equal to Z plus N. Now what is N here? N is actually the number of neutrons. By knowing the atomic number and the number of neutrons, we can find out the mass number of the atom. By knowing the number of protons and neutrons, we can find out the atomic number as well as the mass number. Now there is one more thing, that is that we have to learn that number of electrons is equal to number of protons in the atom. So if we know about the number of protons, we can find out the number of electrons as well. So by knowing the atomic number of an atom, we become able to find out the number of electrons as well. In this equation, you can see that there is mass number, there is atomic number, and there is number of neutrons. If one thing would be missing in it, like we have to find out the number of neutrons here, and we are given with the atomic numbers and the mass number. We can easily calculate the number of neutrons by subtracting atomic number from mass number. This equation will become N is equal to A minus Z. Okay, by subtracting the number of protons or the atomic number from the mass number, we can get the number of neutrons. Similarly, if we are known the mass number and the number of neutrons, we will be able to find out the number of protons again. Okay, like by subtracting the number of neutrons from the mass number, we will be able to find out the atomic number. That is actually the number of protons, and the number of protons will help us to find out the number of electrons as well. Okay, now a few examples are given of hydrogen, carbon, nitrogen, oxygen and sodium. Let's study this example of, say, sodium. Now the number of protons in a nucleus of a sodium atom is 11. It means all the atoms with 11 protons in their nucleus, all these atoms are of sodium atom. Okay, of sodium element. and the number mass number or the number of neutrons is 12. So how can we find out the mass number? By adding number of protons and number of neutrons, and it will give us the 23. That is actually the mass number of the sodium atom. Now I told you that atomic number of all the atoms of a specific element is always same, but the mass number can be changed. Now it means that the number of protons is always same, but the number of neutrons can be changed. So such atoms in which the number of protons or the atomic number is same but mass number is different, these atoms are called isotopes. There is a complete topic of isotopes in the next chapter, and we will study it in detail there. Okay, so for now you only have to learn or remember that there are few atoms in which the atomic number is same but the mass number is different. Now we come to know that why the atomic number is used to identify the atoms. Means that atomic number can never be changed, so it can be used to identify a specific atom. Clear? Okay, the next is the relative atomic mass and atomic mass unit. Now the relative atomic mass of an element is the average mass of an atom of that element as compared to the 1/12 the mass of an atom of carbon 12 isotope. Now carbon 12 isotope, so it means that there are the isotopes for the carbon atom in which the number of neutrons will be different. Now as the atom is a very small particle, very small, and it is very difficult to weigh or to calculate the mass of a single atom separately, so what we do, we compare it with the mass of some bigger element, and the standard element that is decided is the carbon 12 isotope. Now what is the relative atomic? The 1/12 part of one carbon 12 element is used to compare the atom of any other element. Okay, this carbon 12th part of carbon 12 isotope is used as a standard, and we use it to find out the atomic mass of the other elements other atoms of the other elements. The unit of the relative atomic mass is atomic mass unit, AMU. Now what is this AMU? This AMU is the 12th part of that carbon 12 isotope. I'll teach you this topic in detail once we will be in class again. For now you have to learn that this 1/12 part of one carbon 12 atom is used as a standard to compare the atomic masses of the other atoms. Okay, now what is 1 AMU? 1 AMU is the 1/12 the mass of one atom of carbon 12. Carbon 12 atom is used as a relative atom, or is used as an atom to compare the atomic mass, and its 12th part is taken as that standard. Okay, and it is called as AMU, atomic mass unit. Clear? Now the next topic is that we will study is the chemical formulae. Again it is very important, and as we represent the atoms with their symbols, like we use Na for sodium, we use H for hydrogen, we use C by writing the capital letter C, we say that it's carbon. So atoms are represented through the symbols. Now the chemical formulae are used to represent the compounds. Say if you study about the chemical formula of water, we already know that there is present hydrogen and oxygen in it, and H2O is the chemical formula of water, in which H is hydrogen and O is oxygen. H is symbol, O is symbol, and H2O is a chemical formula. Clear? So compounds are represented by chemical formulae as elements are represented by symbol. Chemical formula gives information of elements present in that compound. It also represents the ratio of the atoms of each element present in that compound. For example, NaCl is the chemical formula for sodium chloride. What is sodium chloride? Sodium chloride is a salt that we commonly use in our homes, and it contains sodium and chlorine in it. This Na is the symbol for sodium, and Cl, capital C, and small l is the symbol for chlorine. So NaCl is the chemical formula for sodium. C6H6 is the chemical formula for benzene. Now there are two types of the chemical formula. First one is the molecular formula. Now what is molecular formula? It shows the actual ratio of the atoms present in that molecule. Clear? The formula which shows the actual number of atoms of each element present in a molecule of that compound. It gives the actual number. Like I told you that water, I told you that its chemical formula is H2O. Now there are 2 hydrogen atoms and 1 oxygen atom. So this is the actual ratio. Now let's study the example, that is, in a molecule of benzene, 6 carbon atoms are combined with 6 hydrogen atoms. So the molecular formula of benzene is C6H6. This 6 with C shows the number of atoms that are present in number of carbon atoms that are present in the in the molecule of benzene, and this 6 with the hydrogen shows the number of hydrogen atoms present in a benzene molecule. Okay. Now the next example is of glucose, that there are the chemical molecular formula of glucose is C6H12 and O6. There are 6 carbon atoms, there are 12 hydrogen atoms, and again there are 6 oxygen atoms. This is the actual number of atoms that are present in that molecule. Clearly? So molecular formula gives us the actual number of all the atoms of all the elements present in that compound. The second type of the chemical formula is empirical formula. What is empirical formula? A chemical formula which gives the simplest whole number ratio of atoms present in a compound. It is determined by knowing the percentage composition of a compound. Now it gives the simple whole ratio, like I taught you molecular formula first because then it becomes easier to study the empirical formula. Now look at the example of benzene and glucose. Let's study the example of benzene first. We have studied that molecular formula of benzene is C6H6. The ratio of the atoms is 6:6, means 6 carbon atoms and 6 hydrogen atoms. When we will simplify it, it will become 2:2 and then 1:1. Now the empirical formula of benzene is CH. Okay. This gives it is not giving the actual ratio. This CH is not giving the actual ratio of all the atoms present in a benzene molecule. In fact, it is only telling about the ratio of the atoms, that for each carbon atom there is for one carbon atom there is present 1 hydrogen atom. This is the simpler ratio. Similarly, in the example of glucose, there are C6H12 and O6. Ratio is 6:12:6, which simplifies to 1:2:1. It means, and the empirical formula for glucose is CH2O, which shows that there are present 2 hydrogen atoms but 1 carbon atom and 1 oxygen atom. This is the simple ratio. Okay. Molecular formula and empirical formula of many compounds. Yes, molecular formula and empirical formula for many compounds is same. Like if we take the example of H2O, the ratio would be 2:1. We cannot simplify it further. So the empirical formula and the molecular formula for water is same. Similarly, NaCl, that is sodium chloride, H2SO4 and HCl. All these are, there are more other examples also in which we cannot simplify the ratio, and so the empirical formula and the molecular formula are same. Clear? So if you study these topics in the textbook, you will become able to understand them clearly. Clear? Then the tasks that I would like to give you today, you have to do them on the NEET notebook. There are two questions, numericals. These are very simple numericals, and you have to calculate the number of protons and neutrons and electrons. And so number 1 is calculate the number of neutrons in an atom with atomic number 7 and mass number 15. Number 2, keeping in mind that the number of electrons in an atom is equal to the number of protons in the nucleus of that atom, calculate the number of electrons, protons and neutrons of an atom with atomic number 20 and mass number 40. The next is you have to write about the differences between the empirical formula and the molecular formula. You have to give the examples also, okay? And the last one is the solve all the self-assessments between these topics. Also solve the review questions related to these topics. You have to do this work on the NEET notebooks. Clear, students? Thank you so much. Allah Hafiz.